Good afternoon. I am Prabhakar and will be delivering lecture on data inputting and editing in GIS, also known as digitization in GIS. So, when it comes to digitization or data creation or data editing, few things come in mind. What kind of data we want to create here and what kind of data we want to edit here. Like there can be many kind of digital data, for example census data, socioeconomic data, number of people watching TV. This kind of data can be there, but are we going to create that kind of data? No. Here we are going to create uh, GIS data. What kind of data we represent in GIS? In GIS basically we represent geographic phenomena. And when we have to represent geographic phenomena in GIS, or when we have to create any data, few things come in mind. What kind of data will be created? What will be source of the data? Then how it can be created? And when it is being created, what are the data model to store the data? When we shortlist our model to store the data, we need to narrow down to the format to store the data. So we'll focus on these things one by one. First, source of the data. How we will be creating the data? We will be getting data from few sources. Some of the sources are direct sources of GIS data. Some are indirect sources. For example, field survey or ground data. We can go to the ground with handheld device, which can be GPS, or your smartphone which has GPS. So with these kind of handheld devices we can get the data in the form of point, a georeference point, georeference line, or area kind of data directly. So getting data from the field using handheld devices, mobile devices, is one of the direct source of the data. Another source is performing field survey. Using field survey instruments we can conduct survey, we can model the building structures and all. So that is again another direct source of data. Then we can have remote sensor mounted on aerial platform, which can be used to perform aerial photography, sensor mounted on aeroplane or helicopter. That is again one of the direct source of GIS data. Then sensor mounted on satellite, that also gives us georeferenced images. So that is again our direct source of data. The data type from handheld devices and data type from the satellite or aerial survey aircraft, and from total stations, so type of the data will be different. We'll see later what kind of data are possible, but we'll see some of the indirect sources. One of the indirect source of the data is topographical map. We can get topographical map from survey department. You can visit Survey of India Nakshe portal. Open series maps are openly available, where you can you just need to enter, uh, you need to log in, create account, login, and then enter toposeat number, and you can download toposeat in the PDF format. So this is one of the indirect source of the data, because PDF source is not a GIS data format. We need to do certain pre-processing steps to reach to data in GIS format. For example, once we can have toposeat in the form of PDF, or we can have toposeat in the form of printed map, which can be scanned. So when we have scanned map, we need to or when we have printed map, we need to scan it first. After scanning, we need to georeference it to assign the geolocations in certain coordinate system. Then after georeferencing process, digitization can be performed to create vector data over scanned toposit. So due to these steps involved between the printed map and data creation process, so this is one of the indirect source of the data. Then uh, data available in the form of map services, like you can have certain web map services, you can visit open series map, you can view the map, but you cannot directly download all data. Some data is available to download, some is not. So when in OpenStreetMap, some of the data is available to directly download. Depending on the location you zoom in, you will be able to download data in the form of point, line and polygon. But when data is in the form of map services, web map service, you cannot download the data, you can just visualize it. But if you have to create data from your WMS layer, you need to do certain processing steps to digitize data over WMS layer. So that is again indirect source of data. So when we learn about sources of the data, some are direct, some are indirect, like satellite, ground survey, toposit. These are some of the sources of GIS data. We have to think about models to store the data in the next step. So suppose we have decided we will be creating data from the toposit. So once we have scanned it, we have georeferenced it. Now what is the data model available to store the data? So in GIS there are two data models. One is raster data model and another one is vector data model. So raster data model is basically image format. It is in the form of image, and vector data model is in the form of point, line and polygon. So in vector data model, any feature or object on earth's surface is represented using point, either point or line or polygon, depending on size of the object on the ground. Whereas in case of raster data model, your entire region, for example this one, this is the region you want to uh, represent using raster data model. So on ground there is a field representing corn, there is another field representing wheat, another field representing some fruit, flower. So when you have to digitalize this data, the ground data, what you need to do in raster data model, divide entire area in the form of regular grids. So basically there are two kind of data models under raster. One is regular tessellation and another one is irregular tessellation. So in regular tessellation, your entire area is divided in the form of non-overlapping cells, where cells are of same shape, size and orientation. In this example you can see this was your area and this is a representation of that area in the form of image. So entire area is divided in the form of cells, which are also known as pixels of the raster. When all cells are of same shape, size, orientation, it is known as regular tessellation or regular raster. So now next step is each cell need to be assigned a pixel value, cell value, also known as DN number, or digital number need to be assigned here, which is known as pixel value. How this is assigned? Basically, suppose you have this area and you have created this grid. Now you overlay this grid with the area and assign the pixel value based on the overlap of the corresponding pixel with the on ground feature. For example, this particular pixel, this is overlapping with the cornfield. Next pixel is again overlapping somewhere here with the cornfield. So up to here there is overlap with the cornfield. So these pixels will get pixel value for the corn. And in raster data model, you can store only numbers, either integer numbers or floating point numbers, decimal numbers, depending on the data type you are going to use. Names cannot be stored in raster data model. So that is why here you have corn, and here you have here one is stored instead of corn. So the process is corresponding to on-ground feature. You need to decide uh, digital number or pixel value. For example, for corn I can decide 1, for wheat 2, for fruit 4, and for this feature 5, and for chlor uh, pixel value 3 is decided. So which means wherever overlap of cell will be there with some field, the corresponding pixel value will be stored. So here in this region corn is stored in this region. For corn 1 is stored for the pixel overlapping this region, 4 is stored, and somewhere here 2 is stored, and in between 4 for this particular fruit. One thing also you can notice, in this case you have this boundary of cornfield which is not very straight. However, when this corn is stored, you can see in this region corn is stored which is perfect square region. So this happens because of the limitation of this data model. So area will be divided in the form of pixels. So one pixel will come here, one pixel will come here, and one pixel will come here, and this pixel another pixel. So there can be situation when one pixel is uh, covering more than one fields or one more than one objects on ground. So in that case, whichever object is having more overlaying region, corresponding pixel will be assigned. So this way, instead of having smooth curve in raster data model, you can have zigzag effect. Either you will have this rectangular or some zigzag effect will be there. Another drawback in case of raster data model is represent aerial representation. Aerial means area wise representation. For example, you have a point. For this case which we have discussed, that this case is for polygons, you can have you have well understood, I assume. But suppose you have a point feature to be represented in the form of raster. Point feature means point like object on the ground need to be represented in the form of raster. So as you already know, point does not have any size or dimension. But when you represent any point, you cannot represent a point, you can represent a pixel in case of raster, and pixel will have some size, width, and height. So instead of representing a point, you will be representing some area which will have area equal to width multiplied by height of the pixel. So uh, this way of storing point like object or line like object will lead to error in area calculation. Why error in area calculation? When point is represented in the form of pixel which will have area, so instead of getting no area for the point, you will get some area for the point. Again same problem will come when you are representing line like object in the form of pixel or raster. For example, you have a line like this and you want to represent it in the form of raster. So raster will have pixels. So instead of having line, and again line has length, line does not have width. So but when if line does not have width, you will not get any area for the line. But when you are representing line in the form of pixels, you will see area starts coming for the line. You will have pixels, and because of the curvature you will get some zigzag. This is zigzag effect because of curves present in the line. So in this case of raster representation, you will have error in area calculation even if it is polygon, and zigzag effect at the boundary of the polygon, and zigzag effect for the line, and you will have area for the point like object. So these are some of the drawbacks. So how this can be minimized or how it can be overcome? So you cannot overcome this kind of error, only this error can be minimized up to some extent, which means if you make smaller pixels or decrease pixel size in case of raster representation, you will get a better curvature representation in raster. Still zigzag effect will be there, still area will be there. So basically in raster we divide area in the form of pixel, and pixel has some value, and that pixel value is the value or characteristic value of the property being represented. Here we have shown example of some land use where pixel value is corresponding to land use. We can use uh, raster data model to represent some continuous field phenomena like temperature, rainfall, pressure, humidity. So temperature is a continuous field phenomena. Continuous phenomena means gradually temperature changes. When, which means if there is gradual change, you cannot make boundaries. So like here in this case, change is not gradual. For example, here left side of this line you have pixel value 1, and right side you have pixel value 4. So jump from 1 to 4 is not gradual, it is abrupt. While because this example of land use, that this example is of discrete field, but when it is continuous field, changes in the values are gradual. Smoothly temperature changes. At one pixel it can be 30 degree, at nearby pixel temperature can be 30.01 degree, 30.1 degree. Suddenly it will not change. So raster data model can be used to represent continuous field phenomena. Also in the case of representation of continuous field phenomena, you need to have data type floating point, which means decimal numbers to be stored for continuous field phenomena. If you are not storing decimal number, the gradual change cannot be captured. For example, here in this case data type is integer, which means only integer values are there. So everywhere 1 is there. If there is change of 0.01, you cannot store here. You can store only 1, not 0.01. So if you are using a data type floating point, in that case the decimal values can be stored. Now vector data model. Vector data model, as I told earlier, it is in the form of point, line, and polygon, which means point, line, and polygons are the basic building blocks of vector data model, which means using either point, you will be representing any object feature on the ground or any discrete field phenomena on the ground using either point or line or area or polygon. So in case of vector data model, you have a point. How point is defined? A point is defined by its location and characteristic properties. So any feature represented using vector data model in GIS that has location information, and along with the location, characteristic properties of that location or that particular object, that is non location based information, also known as attribute information or non spatial information. Example is, for example, one uh, I want to represent one of the prominent tourist place or tourist location, for example clock tower of some city. So that can be represented using point feature. How the coordinates of point will be defined in the form of longitude and latitude. And along with this there will be attribute table created also. So that attribute table will have information of properties of the feature being represented, like it can be name, it can be surrounding area. For example, if I have represented clock tower, the non-special information for that location can be name of the clock tower, when this was built, who has built this clock tower, and how is the locality around clock tower, what is the minimum temperature at clock tower during the year, and what is the maximum temperature. So these are some of the features, these are the some of the attributes corresponding to the feature being created. So the attributes are stored in separately along with uh, uh, along with any vector data being created. So which means whenever you are creating the vector data, one table will always be generated, because table and features both are in interlinked format. Now when line need to be created, so basically line is created by creating so many points. So you can connect two points to generate a line segment, and you can connect two line segment to generate a line, which means one point here and one point here will connect these 2 points, so you will get one line segment. So this is one line segment, connect this point and this point, this is another line segment, this is another line segment, and by connecting multiple line segments you get the line. So how this is stored? In this case, coordinates of all the points are stored, and how they are connected, so that information is also stored. So whenever you create some point, first it will get some id, next point will get different id, higher id basically, and how these points are connected to generate this line, that will also be stored. So when you open the vector data, it will display a line connected. In case of polygons, the polygons basically represent area. So for example, this is one area, this is another area, another area. So the how these area are represented? So basically here again you need to create many points. You can you can connect 2 points to generate one line segment. For example, this is another line segment, and connect multiple line segments to create a line. And when starting and ending point of the line are same, it becomes a polygon. So polygon is basically a closed structure, which means start and end point of the polygon will always be same, then only it is polygon. So in case of polygon, there there are basically two models, not only polygon. In case of vector data models, there are two different models to store the data. One is topological data model and one is spaghetti data model. So whatever I have told, that is spaghetti data model. In case of polygon, how spaghetti data model is used to store the data, basically spaghetti data model is area by area representation, polygon by polygon representation, which means you create and store one polygon. How? Polygon you can create by creating so many points, and start and end point are same, which means connected uh, closed loop will give you polygons. So for in this case, each point used to create polygon will have coordinate value, and how they are connected to create the polygon, that information will also be stored. So for this, for example, one point is created here, one is here. So many points will be created to capture the curvature, and once it is a closed loop, It is a polygon. So this polygon can be created by connecting these points, for example. But when it comes to creating another point, again points need to be created which will be connected. Start and end point same. So in this case, what will happen? This common line or common boundary will get stored twice. Once when this polygon is created and once when this polygon is created. So this increases your data storage size, and this also increases time to perform certain kind of queries. So this is spaghetti data model where you store each polygon separately. In there is another data model, topological data model, where common portions are not stored twice. So in topological data model, instead of storing polygon in the form of polygon, polygons are stored uh, using its segments used to create the polygon. For example, one segment will be this common line, so this will be stored separately. One segment will be this one stored separately, another one. So these are some of the segments which will be stored, one, second, third, fourth. So these four separate segments will be used to create this polygon. Now after creating the after storing the segment, what is in the left side of the segment, what is in the right side of the segment, that information is stored. Basically segment wise information is stored, and how segments are connected to create the polygon, that kind of information is also stored. Based on this, duplicacy of storing the count boundary is removed, and some of the special queries become faster. For example, if I have to find out the adjacent polygons, so for example these two polygons are adjacent one and I have to find out, so easily topological data model can give you uh, adjacent polygons, because this common boundary will have two inputs, one in the left side and another in the right side. Whereas in spaghetti data model, the common bound, to find out the adjacent polygons, intersection operation need to be performed in background basically, and many iteration, basically overlap of all the points need to be checked with the polygon, then only adjacency can be find out. So the in case of spaghetti data model, the process becomes a little bit lengthier. In case of topological data model, easily such kind of operations can be performed. This kind of difference in time taken by software to perform the operation can be noticed when your data size is larger, which means if you are having only 4 5 polygons, doesn't matter in which data model you are storing, you will not there will not be any significant difference in time taken by the computer to address your query. But when data size becomes very large, for example you are handling data for entire country which can have lakhs of polygons, so in that case uh, uh, choice of model to store the data will have impact. Now once we have seen about vector data model and raster data model, next step is okay, we have understood what is our source of the data and what are the data models, but uh, there need to be certain formats which support these kind of data models. File format, for example, you know how image is stored, and you have a mobile device which can capture any image, any photograph, but you need a file format also to store the photograph in particular format. So for example your mobile phones have file format jpeg. Similarly, in GIS, there are certain formats with respect to these data models. Like for raster, there is a TIFF file format, IMG format. There are certain uh, hier- uh, hierarchical data file format, HDF, network CDF format, NC format, uh, it, INV format, HDR, and in case of raster, there are certain databases available to store the data. In open source specialized database you can have to store raster. In case of proprietary like ArcGIS, file geodatabase can be used to store raster data. When it comes to uh, storing vector data, file format for vector data uh, can be like a save file. Save file is one of very popular file format. Popular because this file format is one, it is very old, and it is supported by most, or I would say all the GIS softwares. So that makes save file is a popular file format. Like save file, you can create data in the form of save file. You can open that data, you can edit that data in ArcGIS or QGIS or IGIS or Saga or Eridas or NV. So save file is supported by all GIS softwares. And there are certain file formats like in open source there is geo package, extension is gpkg. So that file format is supported by QGIS. It is new file format to store vector data. And in this vector data you can have a database, specialized database in open source. Whereas in case of paid software like ArcGIS, you can store your vector data in geodatabase, file geodatabases, or a personal geodatabase. But you have to take care when you have to work with different softwares like ArcGIS and open source software also. In that case, you need to really think about file format, because ArcGIS supports file geodatabase format, that is basically geodatabase to store the data. But it is a proprietary format of ESRI, which means you can create data in ArcGIS, but you cannot create in a QGIS. So which means you want, suppose I have created data in ArcGIS in geodatabase format and I pass on to you, and you have QGIS software, so you will be able to just open and visualize that data from geodatabase, but you cannot do any alteration, means editing is not possible in QGIS for uh, file geodatabase because of the license issue. So once file format is decided, there are few more things left, with like digitization steps. What can we do to digitize the data? Then when we are digitizing the data, when we are creating the data, there is a possibility of having errors. So what kind of errors are possible and how these errors can be removed? So now we'll focus on these things. So uh, suppose you have this kind of suppose you have this kind of map which have only two colors or only two features. One is foreground and another one is background, which means easily you can see features in one color and background in one color. For example, in this example, for example in this case, you can see contour lines are represented in green while background is white. So easily the contour lines can be separated by the software using a segmentation technique, and the colored portion which is foreground, which is contour lines, they can be easily extracted and stored. So which means automatic digitization method you can use in such cases where simple document is there, which means complexity of the features is not present, and easily foreground can be separated from background. So in this case you can use automatic methods which require very less interpretation. Next one is this middle kind of map which have uh, complexity in between simple and complex. For example, in this case, you have to digitize the lines, but some name is also written in the map. Suppose you are having a printed map which is of this kind, where some name is written and some uh, lines or some polygons are made. So you can scan the map and later start do the georeferencing and then perform digitization. So automatic digitization, if you are using here, it will create shapes for the or polygons based on the shapes present in this map, and along with this the boundary of the letters in this word will also be created as a GIS feature, which is actually not a GIS feature. This name is not related to GIS feature. These shapes are GIS features. So a little bit manual interpretation or manual intervention is needed to get rid of these kind of issues which may be present in some document. Then there is a complex document, for example, a typical topo sheet. I don't know how many of you have seen the topo sheet. Topo sheet basically has a lot of information. It has settlement information, it has river body information, land cover classes, it has contour lines, sea, rivers, lakes, roads, railway lines. A lot of information is present in topo sheet. So if so many informations are present in topo sheet, it gets very difficult to perform automatic digitization, because system will get confused and it will not be able to uh, create the polygons as per the actual shape and size present. So, manual digitization methods are preferred when it is uh, when your map document is having complex features. However, these days you can see some of the AI based tools are available. These tools you can find in QGIS in the form of plugins. So, these AI based plugins can help you to lower your efforts to digitize or create data over complex map document, for example toposheet. So when we are digitizing any uh, line or polygon or point, few things we have to take care. For example, we'll talk about digitization of road network. So for example, this is the road network, this dark red one. So when it is digitized, what how it can be digitized? I can make one click here, another click here, then at the end. What I mean, one click here, one here, and at the end. So with just four points, also known as vertex of the line, with just four vertex, we can create this entire line, which is a road. And to digitize this road just with two clicks or two vertices, this road can also be created. With just two clicks, this road can also be created. So when road is created in this form or line is digitized in this form, next step is feature forming or editing step. Because in reality, if you see at very broader level, all roads you will see they are connected, but names of the road changes after certain junction. For example, this particular road segment is having road name as Rajpur Road, and this particular segment of the road has name Saharanpur Road. But when this line was created, how did I create? I made one click here, 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 here. So with just four clicks, I was showing one click was here, 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 and here. With these four clicks, this one was one feature created. One feature created means this entire feature will have only one entry in attribute table. So as I told in vector data model, whenever you are creating a line or a polygon or point corresponding to each point created or each line created or each polygon created, there will be one record added in attribute table. One record added means one row will be added. So which means for this line one row will be added. But as I told, this portion of the line is Rajpur Road and this portion of the line is Saharanpur Road, which means two names need to be stored for separate portion of the road. In that case, what need to be done? This feature which is currently one feature need to be splitted in two. So if I can split this feature in two, we'll get two entries in attribute table. For one I can store different name and for another different name can be stored. So this process is known as vector editing. First we have formed the features, then we will edit the features, then we'll structure them. So we are basically structuring and then association of attributes. So these process, basically these all steps can be done together when you take some precaution while creating the data, which means while creating the data, if I know this portion of the road is having different name, so I will create one road and end up to here and add the name of this particular road, then we'll start digitizing another portion, and when I will end this particular segment of the road, the different name can be added. So either you take precautions and do all the steps together, or you create once and perform editing and then structuring. So this is one, different names for different segments is one of the need for structuring. There is another need when road is created. For example, in this road, we have seen one point was created here and another point was created here, and this entire road is generated. But suppose I want to find out shortest route between this star location and this location. So it appears shortest route is this one, but software will not give you this as the shortest route. Because how do you know this is shortest route? I can see that there if there is this can be shortest route only if there is junction present here. So then only I can move from here to here and take a right turn and reach up to this. If there is no junction present here, you cannot take the turn. So basically, if junction is present on the ground, the same junction need to be marked in the data, which means if you are created this entire line just by two clicks, one is this one and one is this one, junction is not created here. So you cannot find out shortest route this way. So what you need to do, you need to do editing and add one junction here like this one. So adding junction is basically adding a node. So when you add a junction, add a node here, then basically lines get connected at that particular uh, junction, that particular node, and now you can find out shortest route. So when lines are connected at junction, then only resources can flow. Same is the case for here, junction is not created here, so you need to add a junction. It is not necessary when it appears they are crossing you need to create the junction. For example, when there is no connection, there is a possibility it appears from the top that these two are connected, but there is a possibility this is overbridge. So if it is overbridge, you cannot go and take turn. If it is overbridge, it is not connected at this point at least. So that is why here you can see no junction. So these things you have to take care while creating the lines. So and when creating the lines, the attributes of the line can be stored. Attributes can be name of the road, then type of the road, width of the road, when this road was created, it is highway, state highway, national highway, or it is village road or district road or colony road. So that it is it one way. So these kind of information need to be stored corresponding to each feature created. The attribute association process we have already seen for polygon, so I'll skip this. Next is data checks and repairs. So why we need data checks? Data checks are needed for consistency and completeness of the data. So this kind of requirement is needed. Basically, data checking is needed for to access the geometric quality. What do I mean by geometric quality? The position of the object. For example, few points are created. Are these points created at exact location or there is deviation? These boundaries for the polygons are created. Are these boundaries present at the exact location on the ground? So for this assessment of geometric quality, ground data is needed, or along with the apart from ground data, you can also have reference data, which reference data should is the data which uh, for which you have strong reason to believe that this data is of good quality. For example, if I have to digitize state boundaries of India, so once I have digitized, I need to do quality assessment. I have to find out how accurately I have digitized. So to get the accuracy of the boundary digitized, either I can go to the ground and collect the coordinates of the actual boundary of the states, or I can search, I can look for existing data which is having good quality. So I can get the data from Survey of India, which is the authentic organization for the political boundaries. So we can get the data from there and match our created boundary with the Survey of India. So since Survey of India does the accuracy assessment and all, there are many good reasons to believe that uh, boundary you get from the Survey of India which is authentic and it is error free or least possible error. So considering that second data set as a reference, you can access the quality of the data. Then yes, topological quality, like there is overlap or not. For example, one polygon is created in this way, another polygon is created here, so there is overlap. So this is topological issue. Polygons cannot be overlapping. So topology is basically the spatial relationship which is invariant under transformation, continuous transformation. So it is based on three properties: continuity, contiguity, and containment. So which means whatever is present in left hand side of particular arc will always remain in left hand side. But here it is violation. Left side, left side is polygon A, right side is polygon B and A both, because there is overlap. So this is topological issue. So to check the topological quality, you need to define the topological rules, which means what kind of issue you want to identify. You want to identify the overlap of two polygons, or you want to identify gap between two polygons, or you want to identify overlap of polygons in one layer and polygons in another layer. Then semantic quality can also be checked for quality assessment purpose. I will say example of semantic quality. For example, this is a river, and on side of the river there is road. So whenever you are creating the data, you have to take care that road should not cross boundary of the river. For example, river is created in the form of polygons, and when I digitize road, I have digitized in this way, where you can see road is overlapping with the river, which is not possible. Semantic accuracy is not there. So in that case, what will happen? You will face geometric issues, overlapping of one feature with another one, which is naturally not possible. So these few things you need to take care while performing digitization, and there are certain common digitization issues which also need to be taken care. One is overshoot, which means your line this line need to be ended up to here, but it has some hanging portion, that is known as overshoot error. Then you can have undershoot. Your this line need to be connected to this point, but it is not, there is certain gap, so this is undershoot. Then you can have duplicate lines, you can have gap, you can have means you can have duplicate lines, means one line was sufficient here but still another line is created. Then you can have sliver issues, gap between the polygons, overlapping polygons. So some of these errors can be minimized by taking certain care, and some of the errors need to be checked later on. For example, quality assessment, geometric quality assessment need to be performed after you create the data, while overshoot, undershoot, sliver, duplicate lines, these issues can be taken care in the beginning itself by enabling tolerance. So what is the tolerance? It is a minimum possible distance between two features. So tolerance can be between point to point, it can be point to line, it can be point to end point of the line, it can be point to start point of the line, it can be uh, line to line. So definition is same. It is minimum possible distance between two features. So which is a tolerance is basically a radius. So which means once I define tolerance need to be defined before you start digitization. So for example, in this I decide r is radius of tolerance, which means r is the minimum distance. If distance gets smaller than this r, the feature will be connected to center. For example, this is one point and snap tolerance is r, and which means within the radius circle of r, if you create any other point, for example here I can create a point, but if I try to create any point inside this circle, you will not be able to create. It will get overlap exactly overlaid over the existing feature. For example, this one here, you have these three, one two three, these three lines, another line you are creating, and node tolerance is enabled. So when you will create any other point, if this distance is less than the tolerance limit, so this point will move and it will add to the existing point. So what benefit you are getting from this? The small error, which is undershoot error, will not be there, because undershoot error you get because of very small gap between existing feature and new feature you create, that too purely because of ignorance. So if you enable tolerance, features will get connected and you will not have any gap. So where else tolerance can be used? One you have seen for undershoot issues. Here tolerance can be used, and for overshoot cases also tolerance can be helpful. For example, in this case, you can see smaller portion is hanging. So if this small portion hanging is less than the tolerance value, you will not be able to create itself. For example, by mistake, you if you are performing any click here, so I'm saying by mistake, if you have performed any click here which is within the tolerance radius, it will not create click at the location you have clicked, where instead of that, the click will be created over the existing feature present in that tolerance limit. Then another error is knot formation. Knot formation is self intersecting lines. If you are QGIS user, you can try to create self intersecting polygons, it will not create if tolerance is enabled. So self intersecting means line should be of this kind, where you have created these clicks and the clicks gets connected and you get the line. But suppose by mistake after performing this click, instead of going in this direction, another click is made by mistake here, and now you have created another click. From click means you have created another point. So knot formation can be avoided if you have enabled snapping tolerance, because in snapping tolerance is enabled and new click is within the snapping limit, it will not create, where instead of creating new point, it will create new point. Instead of creating new point at different location, it will create new point exactly at existing location. What I mean, your existing point is this one, new point, I have made one click by mistake, so new point should be created at this location. But if Snapping is enabled, so instead of creating new point at new location, it will snap it to existing point. So this way knot can be uh, avoided. Here some more uh, operations. So, if you have enabled snapping tolerance, or you have taken good care of digitization errors while creating the data, you will not get errors. But there is possibility you have the errors and you have forgot to enable snapping. So you have many overshoot, many undershoot errors. The sliver lines, sliver polygons are there. So in that case, there are certain options to edit the data, which means you don't, if you have forgotten to enable snapping and you have created the errors, it doesn't mean you need to create new data again. For example, this kind of line you have created. So there is snapping tool also. So once you have created this data, you can use snapping tool to extend this undershoot portion, and it will extend and join. The snapping tool can be used to snap these points which are present in certain cluster format, and if that cluster radius is less than the snapping radius, it will join. So cleanup operations can be performed to overcome such errors, this overshoot. So if you give the snapping tolerance limit slightly more than the hanging line, it will delete it, remove it, basically dangling objects. Here duplicate node is created. Either you can delete it or dissolve it. Tools are available here. uh, this is one polygon, this is another polygon. It appears very simple, but suppose when you are creating, you have created one polygon for this, one for this, and one for this. So two polygons, two neighboring polygons having same attribute value, it is not the error. But if you merge those polygons, your number of geometries will be lesser geometries can be handled better. So for that, you can dissolve these polygons and breaking of the lines at the junction. Suppose these two are the roads. By just these 4 clicks, you have created these lines and you have forgot to create junction. And if junction is not created, shortest route operation cannot be performed. So you can use the existing tool to break the lines at the junction. Using snapping, these hanging objects can be removed, and yes, snapping can again be used to uh, remove duplicate lines, because if this gap between the lines is lesser than the snapping, it they will join. So this way you can uh, clean up your data and get digitization errors free data. So this is end of my talk today for GIS data creation. Will uh, take some questions after some time. By that time, you can post your queries in chat box.